Hi, in this tutorial I'll be demonstrating the Bosch lens calculator. This tool is useful for selecting the proper camera and lens type. I often get the question, which camera should I use for my application? Well, to begin with, you'll need to answer the question, does my camera need to be able to A. Detect whether an object is present in the scene, B. Classify what that type of object is, whether a human, an animal, or a vehicle. C. Recognize that type of object based upon its movements or clothing or characteristics of some type. Or D. Clearly identify the object based upon its personal features. This could be a face or even a license plate on a vehicle. It's important to notice that the field of view gets smaller as the object detail improves. This is where the lens calculator can be useful. It helps you determine the needed balance between object detail and the desired field of view. Here I have the lens calculator open and I can select the type of camera that I'll be using. In this case, a Flexidome 1080p. Now it gives me the options for the different models available. I can choose the model. Here I'll pick the 832 VO3 and it automatically determines what the lens setting is on that camera model. If I scroll down to select the field of view calculation, the first thing I'll notice is the object distance, image resolution, and horizontal field of view. Watch as I adjust the focal length of the lens. As you increase, your image resolution will increase as well. The tighter the field of view, the more image resolution you get of any object in that field of view. Notice also that as my image resolution increases, my horizontal field of view narrows. This is in direct proportion to each other. Right below the field of view calculation, you'll see the camera DCRI. This is the detection, classification, recognition, identification metrics I mentioned earlier. This is directly correlated to your image resolution. As your image resolution decreases, your object detail changes from one to the next. The best way to use the calculator is to first determine what your object distance is. In this case, let's say it's 75 feet from the camera to the object that you'll be monitoring. Now we can select Calculate. Based upon the lens setting that was chosen, you'll get an image resolution or pixels per foot calculation. In this case, if the object is 75 feet away and I set my lens at 5.4 millimeters, I can expect that my horizontal field of view will be 80 feet wide and the image resolution will be 24 pixels per foot. That's good enough to achieve recognition level. If you want to be able to identify an object, you'll need to increase the lens focal length. Increase that until you reach a minimum of 50 pixels per foot. 50 pixels per foot is a fairly safe estimate of how much image resolution will be needed to detect a face or a license plate. But pay attention to your horizontal field of view because it is going to narrow as your image resolution increases. Let's do one more calculation with this camera. Let's say the object distance is much further, 150 feet away. Enter that distance and click Calculate. Your image resolution, 27.7 pixels per foot, may not be acceptable. In this case, you'll notice that your lens focal length is set as high as it can go. You'll need to change to a different model. If I select up here the 832 VO9, you'll see that this camera has a much longer focal length, as high as 40 millimeters. When I set it up to, say, 33.8, my image resolution increases, and in this case, gives me a 75.6 pixels per foot. That's good enough for identification. I hope this video has been helpful. Practice with it, and you'll find that it'll be helpful for you too as well. Thank you.